MSI MPG X670E Carbon Wi-Fi Motherboard Overview of Slots and Storage for PCI Express Resource Allocations. As always we say, list your top 5 requirements for a motherboard. And as you go through and itemize that, what's your number 1 requirement? Our number 1 requirement, based on questions we're being asked, is for content creation and rendering. So we're going to look at this motherboard because we are answering a subscriber question Bob has asked and wants to know what our thoughts are on this board. So we're going to go through and look at those resources, and we're going to determine how this motherboard lays out for those resources for this kind of work. So we're going to use our 4 add-in card scenarios. Can we add a quad card? Yes, we could, because the motherboard can bifurcate that slot. Number 2, what about a GPU? That's an option we're going to get into as we look at the resources on the motherboard, CPU, and chipset, because we're going to have to compare design versus implementation. So number 2 would be a video card as an option. Number 3 would be a dual M.2 NVMe adapter, which is a possibility. And number 4 would be, what about, because we have 3 slots, 4 M.2 connectors, 2 to the CPU and 2 to the chipset, and we have 6 SATA ports. Okay, we're going to outline how all those resources allocate according to CPU lanes and chipset lanes. So for that last 3rd slot we're going to have, what if we were to put a capture card in there? This would be a good motherboard for that. Now, because we're on a consumer desktop motherboard, we have to consider resources. Because there's always give and take, there's always something shared, there's always something that's going to have connectors, but you can't use all those connectors. And I want to interject also, if any of you are having trouble with the Ryzen 7000 processors, while it's on my mind, be sure you download, not using the driver that comes with the motherboard, but download direct from AMD for the chipset so that you have the latest chipset drivers, because things are always being worked through. And always double check and see what's going on with the BIOS, because you may need BIOS updates as we step through all these issues. So let's start first with the motherboard and see what we're working with. As the motherboard is listed on Amazon, price is not bad. I don't think any of these motherboards should be over $500. From the MSI MPG X670E Carbon Wi-Fi website. Now the documentation we're looking for, because we're looking for corroborating information as we compare what we're looking at, because we need to figure out what we know to be true. On one side we have the design. That's an absolute. That we'll know to be true. On the other side is the implementation, and that's where it always varies. Every motherboard is different. Every motherboard we have to go through this and sort out these resources, because we have 1 CPU and 2 chipsets. And that 1 CPU, everything to the CPU is PCI Express 5. And what we have through the 2 chipsets is PCI Express 4 and below. We have a primary chipset and a secondary chipset. And anything in the secondary chipset has to communicate with the first chipset so that everything that's plugged into it talks to that, and then that chipset has to talk to the CPU. So everything goes through the channel. Now, the CPU, we're going to have 3 different numbers. 2 numbers given to us by AMD that we're going to look at in the specs. As we look at the processor, usable lanes. Now, we can get in the weeds, and we can also get in a rabbit hole when we start trying to count all the lanes, and it'll get real confusing. So we're going to count the lanes as it relates to the processor, because the CPU, PCI Express 5. But the chipset, the primary chipset, the first chipset, we're going to have 8 usable lanes, and that secondary chipset, we're going to have 12 usable lanes. And we're going to count those out and allocate. Now, what I like about this motherboard, it's a pretty simple layout. So if we're looking for this for content creation rendering, you know, as we look at the 4 add-in card scenarios, there's going to be a prioritization of devices. And we have to decide, give and take, what's more important. So let's take a look at the motherboard specs here, then we're going to go to the manual. To reiterate, the MPG X670E Carbon Wi-Fi, AMD X670 chipset, Ryzen 7000 processor, Socket AM5. Now, when we get to the BIOS manual, that's going to be a generic manual, and the link for that is embedded in the motherboard manual. We'll have that link in the description. It says here we can have 4 DDR5 DIMMs, capacity 128 gigs. Talks about the overclock, how far it can go. Supports dual channel, and that says non-ECC, which is unbuffered DIMMs. Okay, non-ECC would be on-die. On-die ECC is non-ECC RAM. If you had support for ECC RAM, there'd be something in the BIOS for parity, and we don't have that. AM supports the AMD Expo. Now, our suggestion at this point, remember, when you're trying to get this system up and trained, stick to the memory QVL. And what you want to find is if the QVL has tested for sticks of anything. Yes, you can get the system up with as little as 1 DIMM, but because of memory training, because of what's going on, it takes time. And 2 DIMMs is a safe bet. Try it on the default before you enable the AMD Expo configuration to get that memory to bump up, and make sure you got those drivers set once you load the operating system, because you want to minimize, you don't want BSODs or other errors that some people have been having a problem with. So let's keep going on specs, because once we get into this same information that we corroborate in the manual, that's where we're going to get when we go to the block diagram. There's some information there that is not absolute, and I think it's just a typo, but I'll show you when we get there. And as it relates to the CPU, onboard graphics. Now the onboard graphics that's supported by the motherboard is because of the CPU. And as we look at the CPU, and we'll go back to that and reiterate, one HDMI, one DisplayPort, and this also supports DisplayPort alternate mode, which is out of the first USB-C port. We will verify that when we get to the I/O panel. Moving on down, our expansion slots, because this is relevant to slots and storage. One PCI Express by 16 slot. And if you notice here, the configuration supports by 16, by 0, by 4. What that means is, of those 3 slots, that first slot, of which there are 3, that first slot is 16 lanes. And we're going to see this corroborating information when we get, again, to reiterate, into the block diagram where we have a second slot. Those 2 slots that are both to the CPU are both PCI Express 5, but they share resources. And because they share resources, one slot by itself, 16 lanes. When 2 slots are used simultaneously, they each by 8 because they share 16 lanes. They're not dedicated. And then we look at the M.2 drives, because there are 2 M.2 drives to the CPU. So if we count all those, we will do that when we get to the block diagram. And as it says here, PCI_E1, PCI Express 5.0, 16 lanes from the CPU. And to reiterate, PCI_E2, also PCI Express 5, up to 8x from the CPU. But remember, those are shared, so both used simultaneously are by 8 each. And then the PCI Express_E3 is PCI Express 4.0, 4 lanes from the chipset. 4 M.2 drives, and if you notice here, M.2_1, 2, 3, and 4. Okay, 1 and 2 are from the CPU, and 3 or 4 are from the chipset. And we'll differentiate how those resources are laid out when we look at the block diagram. Not everybody puts out a block diagram. ASUS used to, but we're not getting that right now. MSI probably has the best documentation of anybody, not only for the block diagram, but the rear I/O panel identifies where the resource is at that we're going to look at in a few minutes for corroborating information. And 6 SATA ports, and it will support RAID 0, RAID 1, and RAID 1.0. So you can have 2 RAIDs, a SATA RAID or an M.2 drive RAID. And what's interesting on these SATA ports, as we'll see when we get to the block diagram, there are 4 SATA ports on one chipset, the primary chipset, and 2 more SATA ports on the secondary chipset. And I see no information that says there are any exceptions, so that those 4 and those 2 can all be rated together if you choose to. A lot of times when you have separate ports like that, you'll have a separate chipset that goes through that separate chipset before it goes to the primary chipset on the motherboard, and there'll be some kind of a note that says you can't put all those together. We don't have that here. So all 6 of those are free to go. 4 on one chipset, 2 on the other. We'll see that in the block diagram. But I just want to point that out. Now another thing we're going to have a USB-C 20 gigabit, and that's on the rear. And that's important because one thing that MSI is staying away from on the X670E chipset, there's no Thunderbolt 4, there's no USB 4, because that would be 4 lanes that have to be allocated, but it could not be dedicated. It would have to be shared with something, which means if they put that on the motherboard, then there's something else that you'd have to choose to use. They don't do that, which I think is a smart idea. It simplifies the layout of the motherboard, and it simplifies it for you guys, whether you're building a second system or whether you're building your first machine. Keep it simple. And that's what this motherboard does. And Realtek LAN 2.5 gigabit, that's using 1 lane. AMD Wi-Fi, that's using 1 lane with the Bluetooth. Now for the Realtek audio codec, I'm going to mention this now and interject this while we're looking at this. If you were going to use this for a digital audio workstation, this would be a fine machine for that, but you're probably going to want to use a separate audio interface, whether it be something through USB-C or USB 3. You'll have the resources for it, and you'll get a high quality, high definition audio interface. And this would work fine for content creation, but you have that option. We just wanted to mention it. Now, power connectors, one thing we don't have, and we'll see when we look at the motherboard layout, we've got the 24-pin power and the 2 separate CPU powers. What we don't have is a separate power tap that we'll look at when we see the motherboard layout, where a lot of times next to the 24-pin, you'll see down there where the USB-C connection that goes to the front, well, there'll be another port or a power tap to plug power into that so that you get power out the front. This motherboard doesn't have it. I just want to point it out. I'll point it out again when we get to the layout of the motherboard. I like the layout because it gives us a 1, 2, 3 where everything's at. I like to see the plumbing. One thermal sensor, which would be a thermistor, and this also has the tuning controller connector. So I've never seen that available separately, but if you're an MSI customer and have one of the higher end motherboards, that connector would work on this motherboard. Now here's a good direction as we look at the I/O panel. While we're here, I want to take a look at, and we'll look again in the manual and confirm it. Top to bottom, left to right. Look here at number 3 and number 8. That is DisplayPort out, and that is HDMI out. And port number 9 right here, that's the 10 gigabit USB-C. And as we look over here at number 11, that's the 20 gigabit, and that's coming from the primary chipset. Those are the ports that are of primary interest, that if you want to support 3 monitors with the internal video, that'll do it. However, if your requirement is content creation and rendering, then you're going to want a GPU. So let's think about that. Add-in card scenario number 1. If we put a quad card on here, it has to go in that first slot. And we'll see how that plays out when we look at the layout. Let's go look at the layout first. Starting with the motherboard manual, we're going to first go to contents. We're going to be looking at specifications, and I'll mention package contents right quick. Always need to point this out. Whatever you order, be sure you put a camera on it so when you do your unpackaging, you make sure you have received what you've ordered. That's a big issue with some of the things that are going on right now, separate issues, separate video. So be sure and put a camera on it. And also, when you open the package, once you've received what you've ordered, be sure and inventory everything, because if anything is missing, that could be a deal breaker in trying to get the system up and running. Because if you're missing parts, they don't do parts. RMA the motherboard. So the quicker you can get that turned around so you can keep moving forward. Just want to point that out. And yes, the back panel connectors we're going to look at. Overview of components. We're going to start with that because I like to see where everybody's at. Okay, we have 3 slots, and if you notice, all 3 of those, PCI underscore E1, E2, and E3, all of those are by 16 mechanically. However, only E1 is by 16 electrically by itself. However, when E2 is used simultaneously, they each, because they share 16 lanes, they each become 8 lanes. And then the third slot, which is to the chipset, that's 4 lanes. Even though it's a 16-lane slot mechanically, electrically there's only 4 lanes allocated because you only have so many lanes. Now looking over here at the layout of the motherboard, to reiterate what I said about the connectors, right over here on the right side there's our 24-pin connector. A lot of motherboards have another power tap sitting right there to give power to this connector for USB-C to the front. This motherboard does not have that for 60 watts, so you will not have to worry about that. And over here on the right also we have our 6 SATA ports, P1, P2, P3, P4, and then S3, S4. So 4 of these, to reiterate, are on one chipset and 2 are on the secondary chipset. And then there is a USB 3 connection. And there's nothing significant that shows on the I/O panel over here on the left. So we'll have to look at the I/O panel itself. And looking at the M.2 connectors, M.2_1, M.2_2, those 2 are to the CPU, and M.2_4 and M.2_3, those 2 are through the chipset. Now the block diagram is way back in the back of the manual, almost to the end. And according to the PDF manual, it's on page 525. So what we're going to start with is looking at the CPU. All this is PCI Express 5. And counting lanes, and we're going to go back and verify what we have on the CPU and on the chipsets. But counting lanes right here, you'll notice, and this is one typo that I commented about. This says PCI Express 4x16. Well, that's actually PCI Express 5x16. PCI Express underscore E1 and PCI Express underscore E2. So those 2 slots, as you can see, share 16 lanes, 8 lanes each. So that's 16, plus over here on the right, generation 5x4, that's 4 lanes, PCI Express only. What that means is there's no SATA that can be put on that. That's strictly an M.2 NVMe PCI Express drive, but to reiterate, it will not accept an M.2 SATA SSD. PCI only, and that's M.2_1 and M.2_2. So we have 16 lanes on the left, plus 4 is 20, plus those 4 is 24. Now let's go take a look at the specs on the processor. We're looking at the Ryzen 9 7950 desktop, and those processors are coming down. We've got to look at specifications, and we can't use just the surface specifications. We've got to go see full specifications. We're going to verify some information here. First of all, this is 16 cores, 32 threads, supports the AMD Expo, and an indication of the supporting chipsets. We're looking at the X670E. The X670E has the most value, the most of everything the others have to offer. And the X670E is actually 2 chipsets made up of that chipset. And we haven't been pointing this out, but the maximum operating temperature is 95 degrees Celsius. It's made to run a little hot. A little hotter than I like, but it's made to run hot. Now here's what matters most for what we're doing with the motherboard looking at resources. Connectivity. USB support, yes. And where our main concern is right here, where it says native PCI Express lanes, that's native PCI Express 5.0 lanes, total and usable. 28 total, 24 usable. And as we went through the process, 16, 2 8s, plus a 4 and a 4, we get our 16, 20, and 24. That's a pretty easy count. So however you want to mix it, that's an absolute what we know to be true. But how they're allocated on the motherboard, a lot of that can change. Remember, changing one thing changes everything. System memory DDR5 and supports dual channel 128 gigs, and those are UDIMMs, unbuffered DIMMs. Now one aspect that's really fascinating right here, we've got ECC support, and it says yes, requires motherboard support. Okay, keep in mind we've got some other videos we're going to be doing about DDR5 ECC. There's 4 types of schemes for DDR memory. We're only interested in 2, and this motherboard only supports 1. But we have to have 4 components to support it. Number 1, the CPU, which we have. Number 2, the chipset, which that's questionable. Number 3, we have to have motherboard support. And number 4, we have to have BIOS support. And as we look at the specs on the motherboard, what we see is it says non-ECC, which is on-die. So of the 2 types we're looking at for DDR5, one is on-die, which is non-ECC. And if you're looking at a motherboard that has ECC support for DDR5, then it's going to be about ECC DDR5, and it'll say parity. There'll be something in the BIOS. When we look in the BIOS on this motherboard, which I won't take the time to do, there's nothing in there about parity. There is some stuff in there about ECC, but that's nothing to do with parity. So to reiterate, of the 4 things we need, we've only got 1. What we need is AMD to clarify and qualify what they say about the chipsets and what's going on with the motherboards, because that's 2 different types of memory. You've got your consumer memory, this is a consumer motherboard on a consumer chipset, and then you've got your industrial or your corporate or your workstation type memory, which would be ECC. And DDR5, even though they're having issues with it and growing pains, it's the future because both AMD and Intel are supporting it. But I wanted to point this out because I think it's important, because we're going to be hearing a lot more about that in the future. Now, graphics capabilities. This is important because we have integrated graphics, it's Radeon graphics, and it's 2 GPU cores. And it supports the USB-C DisplayPort alternate mode. So when we're getting video off of this motherboard, out of those 3 connectors that we're going to look at on the I/O panel, again, to reiterate, all 3 of those, DisplayPort, HDMI, and the USB-C 10 gigabit port, all 3 of those are video out of the onboard GPU. I've had some people ask questions about that, so I'm trying to emphasize so we can explain that as clearly and as definitely as possible. And I still want to go through the 4 add-in card scenarios to understand how the resources are allocated. Now the next resource we need to look at is the AMD Socket AM5 Chipset. And as it says, built for advanced PC gaming and, to some extent, content creation. Well, I prefer dedicated resources. Anyway, let's look at the chipsets. And the X670E, this is the chipset we're focused on. And the specifications right here are what matters the most. Right here it tells us 1x16 or 2x8, which is what we've talked about and verified. So that we know to be true, that's a constant. Then for NVMe, we have 1 4-lane PCI Express 5.0 plus 4 more PCI Express lanes, which are general purpose processor lanes. Now, one thing they've done here that I wish they wouldn't is talks about usable lanes, and they've added all that up. PCI Express 5 and PCI Express 4. Now, granted, there are 24 lanes on that CPU that are usable that we've added up and we'll add up again. But to lump all the other lanes together with chipset, that needs to be separated. CPU lanes and chipset lanes, 8 lanes and 12 lanes versus those 24. So understanding where those are allocated helps us to understand how they're allocated. So now that we understand the design, which we know to be true as an absolute, we'll get back to the implementation, which is where things vary. To reiterate, this is a real simple laid out motherboard, and we only see 2 shared resources. and that's on those two primary slots to the CPU. Let's go back to the block diagram. Now we've allocated lanes on the CPU. If we were to try to count to 28 for the other 4 lanes, then we're looking at the USB-C 10 gigabit, which is DisplayPort alternate mode support on that, plus the other USB 3 10 gigabit ports. And those should add up those other 4 lanes. Now, 4 more lanes that are not talked about and accounted for, which would take us from 28 to 32, would be the 4 lanes from the CPU, which are PCI Express 5, downgraded to PCI Express 4 to that primary chipset. And then the primary chipset connects to the secondary chipset. And to reiterate, anything through that secondary chipset talks to the first chipset before it talks to the CPU. So that's what I call absolute lanes, but consider the source and take it with a grain of salt. Let's look now and see how we do with the chipsets. Now chipset A, and we're counting usable lanes. We have a total of 8. Right there, generation 4x4. Again, to reiterate, PCI Express only. No SATA M.2 SSDs. Only M.2 NVMe PCI Express SSDs. M2_3, only 1. 4 lanes. And then there's our 4 SATA ports. So that's 8 lanes. And then the other lanes that we are not counting, which would be part of the total lanes, would involve this 20 gigabit USB-C port, which goes out the back, these 10 gigabit USB 3 ports, and then these USB 2 ports that are piggybacking. So we've accounted for 4 and 8. Going down to the secondary chipset where we should have 12 lanes. On the left side, generation 4x4, M.2_4, 4 lanes. The Realtek LAN should be 1 lane, and right here is 2 SATA ports. And right here, which is 2 lanes, and right here is the third slot, which PCI Express 4.0x4, PCI_E3. And depending on how you count the lanes, if we count 4, 8, that's 9 and 10. And if we move this up just a little bit, we'll see here with the Realtek LAN and the Wi-Fi, that could be the 12. Depends on how they count. But I'm not going to get in the weeds or down a rabbit hole. All we want to account for are usable lanes, because now what I want to do is go down through the specifications within the motherboard manual and see how that works as we reiterate information. The only conflict we saw was in the beginning. Let's take a look at that again. Up here, as we look at the CPU, where it talks about these being PCI Express 4. To reiterate, those are PCI Express 5 because they're to the CPU. Now let's go to specifications in the manual, motherboard manual. And to reiterate, we're working with a Ryzen 7000. We looked at the CPU. Just to simplify things, all of the 4 CPUs listed all have support for the 2 GPU cores that are built into the CPU. Just wanted to point that out. And we're looking at 16 cores, 32 threads. We're looking at the AMD X670E chipset. We have 4 DIMMs DDR5 up to 128 gigs. And remember to stick to the QVL. We're getting a lot of reports from people that are trying to use memory or they're combining kits and they're having problems. So stick to the QVL. If the QVL says they've tested 4, then consider that, because you've got to balance all those numbers. If they haven't tested it, and there's 2 ways to go at this. One from the QVL from the manufacturer, but pick a brand like Crucial, Kingston, ADATA, or somebody else. Drill down using their memory configurator, plug in the motherboard you're looking at, and see how those 2 line up to see what the motherboard manufacturer says and to see what the RAM manufacturer says. Then if you have any questions or doubt, contact the RAM manufacturer that you want to use and ask them if there's any specifics that you need to know to get that RAM working in the quantity and speed that you want. Until it's tested, it's not on the QVL. It's going to take time to sort all this out, but you need to be aware. And to reiterate, dual channel, non-ECC, which is on-die, AMD Expo, and this repeats the 3 PCI Express by 16 slots, by 16, by 0, by 4, by 8, by 8, by 4. From the CPU, PCI Express _E1 and PCI Express _E2, whereas E3 is from the chipset and it's PCI Express 4. And onboard graphics gives us 1 HDMI, 1 DisplayPort, and 1 DisplayPort over USB-C, which is DisplayPort alternate mode. We'll verify that when we look at the I/O panel. 6 SATA ports, all from the chipset, both chipsets. And right here, the M.2 slots. 4 M.2 slots, M.2_1 and M.2_2 from the CPU, both are PCI Express 5. M.2_3 and M.2_4 are from the chipset, and both of those are PCI Express 4. And various links, M.2_3 can go all the way up to 22110, whereas the other ones are all, it looks like, 2260 or 2280. And to reiterate, RAID 0, RAID 1, and RAID 10 if you choose. Now the add-in card scenarios. Number one, can you install a quad card on this motherboard? Yes, you can. And what I want to do is go back and, as we talk about this, let's take a look at the block diagram. If that PCI Express 5.0 by 16 slot PCI Express _E1 is used for a quad card, because remember a quad card is 4 drives and the slot has to be bifurcated. I'll show you what it looks like in the BIOS in a minute, but that's 4 lanes for each drive. So 4 by 4 by 4 by 4. 4 by 4 is 16. Full bifurcation, BIOS bifurcation. So you put, and if that's your priority, you put that in that first slot. That means you cannot use the second slot. You have to forget it exists. Because if you use the second slot, that first slot goes to 8 lanes and you'd only see 2 drives. So then the question becomes, remember, we're about content creation rendering. If we've gone through what it takes to get the quad card working, and if we accept the fact and know to be true that that can't work if we need a GPU, and if we need a GPU for rendering, because to reiterate, the GPU can do 80% of the rendering, then guess what has a priority? The GPU has a priority. So scenario number 2 would be the GPU in that primary slot, 16 lanes. That's a given. Now, what about the next scenario, the third scenario, which would be if we put a dual M.2 NVMe adapter in that second slot? That'll be fine. That means your video card would then use 8 lanes. It'll be fine. Then you would have 8 lanes on that second slot to the CPU, where you could bifurcate that in the BIOS, and you'd have 4 by 4, full BIOS bifurcation for 2 drives. Now, the next question is, even though that's a PCI Express 5.0 slot, this motherboard is not designed to handle one of the cards for PCI Express 5 to do multiple cards. In other words, I don't think there's a setting in the BIOS for the redrivers for the PCI Express 5. So if you're trying to get hold of one of those cards, there's one card that's been announced by Gigabyte that is a quad card for PCI Express 5. It's probably a year away because there's other cards they've announced that still haven't seen the light of day. It's the Gigabyte Aorus Gen 5 AIC. It'll take 4 drives. And from what they say in the press release, I'll get a link up since I'm talking about it, it's only going to be sold populated, not unpopulated. Should be a fascinating card, but I wouldn't put it on this motherboard because this motherboard is not designed for it. What you're looking at, if you put a quad card in that first slot, would be PCI Express 4 or PCI Express 3, but not PCI Express 5. To reiterate, because it doesn't have the redrivers to push it. And if you're looking to get one of the other cards for that second slot for 2 drives, I would stick with something, again, PCI Express 3 or PCI Express 4, not PCI Express 5, because the slot's not designed for it, and use something like the Supermicro Dual M.2 NVMe adapter. We'll get a link up to it. Great card. All you have to do is figure out some heat sinks, and we've tested lots of heat sinks. So what's our next scenario? That other slot. We've accepted the fact, and we know to be true, what our lane allocations are up to the CPU, how that works out. So we're not going to put a quad card in, but we're going to put a video card in. Okay. We could put a dual adapter in if we choose to. But for the third slot, because that's to the chipset, let's take a look at that. And the chipset we're looking at for that slot is in the secondary chipset. And to reiterate, that's PCI Express 4, 4 lanes, PCI _E3. And on the overview of components, that would be that third slot. And that would be a great place to put a capture card. Now, a 4-lane capture card, any one of the 2 consumer cards would be great in that, but you could also put a professional card like one of the, because we've had questions about this, like the Blackmagic DeckLink cards that use 4 lanes. It would work in this scenario. It's a dedicated slot. So as all the resources are laid out, this is a pretty good simple motherboard. There's not as much give and take as we've seen on some of the others, which are quite a conundrum. Back to the M.2 drives. Your best location for your 2 PCI Express 5.0 drives are the primary and the secondary location on this motherboard, and those are dedicated. And then you have space for 2 PCI Express 4 drives through the chipset. Now I want to point this out and think about it. So you've got 2 drives to the CPU and 2 to the chipset. These can be PCI Express 5, and these 2 can be PCI Express 4. I wouldn't RAID all 4 of those together. If you want to RAID those 2, fine. If you want to RAID those 2, that's fine. 1, because of latency, but 2, because PCI Express 5 CPU and PCI Express 4 through the chipset. And you can do RAID 0 or RAID 1 with 2 drives, and you could do RAID 0 or RAID 1 with those 2 drives. Now, if you want 2 more drives to go PCI Express 4, that's an option for that second slot, where you could put in 2 M.2 NVMe drives. That would be PCI Express 4. Then you could RAID 4 drives. 2 on the motherboard to the chipset, and those other 2 that are yes to the CPU, but they'd be PCI Express 4. You could. I'm not saying it would, but I'm saying you could. Because if I don't answer it, someone's going to ask. Because we get a lot of what ifs. And as far as which motherboards are appropriate for whatever, our goal with these motherboard overviews are to show you and help you understand resource allocations for PCI Express. CPU, chipset, slots, and storage. And I like the layout of this board. Let's look at the I/O panel now and see how that comes out. Now to reiterate, on these back panel connectors, number 2 and number 10, DisplayPort out, HDMI out, and then number 11 is that 10 gigabit port for DisplayPort alternate mode. That's how you're going to support 3 monitors with the onboard video if you choose to. And then number 13 over here is the 20 gigabit port, 2x2. I want to point out those resources because we've been asked, and I'm going to show you now the key that gives the very description of where that comes from because it's in here with MSI. Got to show you. For example, this number 13, it shows right down here, USB-C 20 gigabit 2x2 from the X670 chipset. And remember, the 10 gigabit port, this DisplayPort alternate mode, is coming from the CPU, and that 20 gigabit port is coming from the primary chipset that's on the I/O panel right there. 3 slots, we talked about those. The 4 M.2 connectors, 2 to the CPU and 2 to the chipset, and how all that can work out. And we've talked about the I/O panel, where all those resources go for video onboard, because if you're using this for a DAW, you could use the onboard video. You wouldn't have to have a video card. But if you're using this for video rendering content creation, you're going to need that video card, whichever one you choose to put in. It's going to work. And if you decide to put in one of the capture cards, you've got a slot for it. The resources on this board, to reiterate, are laid out real well. Price is not bad on the motherboard for what it is. Price of the CPU has come down, which I think is great. Be sure and use the latest drivers. Now, the next point. Okay, we're looking for bifurcation so we can bifurcate a slot. And what we're looking for in the motherboard manual is lanes configuration. And the setting is PCI_EX lanes configuration. And to reiterate, PCI lanes configuration is for the MSI Expander, Expander Z, and other M.2 storage cards. And I want to emphasize the point that should be for anything that's PCI Express 4.0 or PCI Express 3.0. But I wouldn't do this with PCI Express 5 unless the slot had the redrivers for PCI Express 5 to give that the power it's going to need to get that signal out. So even though you can do bifurcation on either one of those 2 slots of the CPU, just be mindful of that. I'd be careful. And that's the setting you're looking for. And that's in the menu on the manual for Advanced PCI Express/PCI Subsystem Settings. And that's what it's going to look like in your BIOS. This says for PCI_E1 lanes configuration, which shows the 4x4x4x4, but the same thing will apply not only to the first slot, but the secondary slot if you want to put in a dual adapter. Now back to the BIOS manual. If we do a search in the manual just for ECC, this will say this enables or disables DRAM ECC. Okay, this is for on-die. If there was something in here that said something about parity, and I'll do a search for parity, there's nothing in there about parity, only ECC. So that's on-die. Okay, to reiterate on the specifications, we've covered the CPU, we've covered the chipset, we've covered the RAM, we've covered the slot configurations with the opportunity of how to best configure and how to use those slots. We've talked about the onboard graphics, we've looked at the I/O panel and how that works. We've talked about the 6 SATA ports, and there's no exceptions. Those can all be rated if you choose to. We've talked about the M.2 connectors, of which there are 4. To reiterate, 2 to the CPU and 2 through the chipset. We've talked about the RAID, about the onboard audio, a little bit about the Realtek LAN to the extent that it uses 1 lane, and the AMD Wi-Fi also uses 1 lane. We talked about the power connectors. To reiterate, there's not a power connector to get power out that front port for 60 watts. Some motherboards have that, this one doesn't. This is a real clean, simple board. For someone that's looking to build a machine, especially a first-time build, this would be the easiest build to go with. So Bob asked about this. We're answering subscriber questions. I hope you find this helpful. I want to thank you guys for watching. If there's something else you've got a question about or a comment or something else you want to know about on another motherboard, please ask. We're here to help. Welcome. My name's Gil Boyd. This is BuildOrBuy. We look forward to seeing you next video. We're out.